If Earth has anything like a twin in the solar system, Venus is it. Venus's mass is about 0.81 that of Earth's. Its size is roughly the same. Its radius is 6,052 kilometers, 3,760.5 miles. Earth's is 6,378 kilometers, 3,963 miles. Because their masses and sizes are so comparable, that means that they have roughly the same density and thus the same composition. However, in other ways they couldn't be more different. Venus has a surface temperature of nearly 482 degrees Celsius (900 degrees Fahrenheit), and the pressure of its carbon dioxide atmosphere is 95 times that of Earth's atmosphere. Its clouds are sulfuric acid. Venus's surface is an inhospitable wasteland. Much of the interest in Venus is concentrated on how two planets so similar could be so different. Because Venus's atmosphere is so thick, the planet is subjected to an enormous greenhouse effect that heats the planet. Even though Venus is much closer to the Sun than Earth is, it absorbs less sunlight because of its thick clouds. However, enough sunlight makes its way down into the lower atmosphere and the surface. This sunlight is absorbed and re-radiated as infrared radiation. On Earth, the infrared radiation goes back into space. On Venus, the thick carbon dioxide clouds trap the infrared radiation, heating the planet. If you looked down on the solar system from somewhere above the Sun's north pole, you would see the Sun rotating in a counterclockwise direction. All except two of the planets would be rotating the same way. Venus rotates clockwise on its axis. Its day is very long, 243 Earth days, which is even longer than its year, 225 Earth days. The other spinning oddball is Uranus, which spins on its side. It's still an open question as to why Venus spins the other way. Solar tides acting on Venus's very dense atmosphere or collisions with large bodies in the past are suspected. While Venus slowly turns on its axis every 243 days, its upper atmosphere whips around the planet underneath it every 4 days. Why? Speculation is that this super-rotation, as it's called, has something to do with thermal tides induced by the Sun, but a definitive cause is not known. Venus's superrotation was found by observing the motion of dark streaks in its atmosphere. What these streaks are and why the superrotation hasn't mixed them evenly through the atmosphere is unknown. The streaks do observe ultraviolet light. One possibility is that these streaks are evidence of microbial life. Venus's surface is nearly 482 degrees Celsius (900 degrees Fahrenheit), but between 50 and 60 kilometers (31 and 37 miles) above the surface. The temperature and pressure are like those at Earth's surface. But what about the sulfuric acid clouds? The microbes could be coated in molecules of 8 sulfur atoms S8 that would be impervious to sulfuric acid. S8 also absorbs ultraviolet light,